Hello student, very good morning to all of you. I hope you all are happy, healthy and fine at home. Did you remember what were we discussing yesterday? I think we were discussing about the synthetic application or different compound we have prepared using starting from the acetoacetic ester. And now today what we are going to discuss over here, look at here Wittig reaction. First of all, what do you mean by the Wittig reaction? Wittig is a scientist name. He discovered one of the method, or he prepared as a phosphorus elide. And as we know that in 1954, George Wittig, he prepared the reagent, and that reagent treated with the carbonyl compound and form specifically the reaction obtained is a regioselective at that particular carbonyl compound get converted into as a carbon-carbon double bond. So, and that's why he awarded by the Nobel Prize due to his noble work in this field, and that's why it is known as a Wittig reagent. And that reagent is a versatile synthon, a variety of the organic compound, different or the several compound we can prepare by using that reagent, and that's why it is has a very useful application as a synthetic point of view in organic chemistry. And what he did when he prepared as a phosphorus elide, and that phosphorus elide, as we let us see as a general statement regarding that Wittig reaction. General C double bond O carbonyl group is there, and suppose there is a Wittig reagent R and R, then double bond over there PPH3, right this, like this. So this type of the compound, this is called as a phosphorus elide. Phosphorus elide. This is a elide, the specific name of this. And what is going to happen, and this phosphorus and oxygen has the driving force behind it, and that affinity between phosphorus and the oxygen atom, and the resulting compound is obtained as a double bond, suppose as a C R dash and R we can call it. This type of the alkene is obtained over here. Remember, alkene is formed specifically, and that's why it is called as a reaction. Now if you look at as a mechanism over here, mechanism of that elide, suppose let us see here C double bond O, and then here R dash R we can write here, P always P here negative charge and positive charge we can put over here, negative charge on that carbon, and that's why it is a Carbanion reaction, and then PH3. Now this negative charge attacking on a carbonyl carbon which is electrophilic in nature, and this is the attacking, that double bond is attacking over there and form the resulting compound is known as this one O, then C, this R dash you can write that R, then here P, the bond between this phosphorus PH3, and when this four membered ring is formed involving two heteroatom, one is a oxygen and one is a phosphorus, this type of the intermediate form is called as a betaine. This is called as a betaine formation, right? This is a betaine intermediate is formed during this process, and now this betaine is very unstable. What is going to happen? The bond between this is forming, because the driving force behind it, the oxygen and the phosphorus has a great affinity towards itself, and therefore they are forming as a double bond over there, and this bond is breaking and forming as a double bond over there, and you are going to get here double bond C R dash R, formation of the alkene, and O double bond PPH3. So this is called as a general alkene formation, and this compound is known as a triphenylphosphine oxide. Triphenyl, this is a triphenylphosphine oxygen, phosphine oxide. This is the name of this compound, right? So this is a general structure or general alkene we are getting here. For example, here best example will be, let us see over here how we can show this type of the Wittig reaction or the application of that Wittig reaction. Suppose we have the compound like pH, as we know that pH is nothing but as a phenyl group, pH, suppose as a double bond O and pH over here. The name of this compound is a benzophenone, right? The name of this compound is a benzophenone, and when this benzophenone further treated with the Elide, that is a Wittig reagent, and as we know that Wittig reagent is this one plus Wittig reagent, generally here suppose as a CH2 and then here is a minus charge phosphorus PH3, it is a positive charge, this is called as a Wittig reagent. This is known as a Wittig reagent, and generally what is going to happen, the negative, this negative charge. Now let me draw this one is a properly over here so that we can show the mechanism also. Here here is a minus charge, CH2 minus charge we can write over here, and here is a PH3, here is a positive charge as we know that. And now this negative charge attacking on that carbonyl group, and the lone pair or this double bond can attack on that phosphorus, and we are going to get pH. Then this pH as it is, then I am writing over here this oxygen atom with phosphorus pH3, and this will be with that CH2, and this is called as a betaine formation, right? Betaine, when this betaine intermediate is formed, what is betaine? At that time you have to show this type of the betaine we are getting, and now this oxygen forming as a double bond with phosphorus, and this bond is forming with that CH2, and we are going to get the product, this one pH, then here is a pH double bond CH2. What will be the name of this compound? The name of this compound is here 1, 2. At one position there are the two phenyl groups are there, and therefore we can call it as 1,1 diphenyl ethylene, or you can call it as a 1,1 diphenyl ethene. So this is the IUPAC name of this compound, and by using as this Wittig reagent we can prepare a number of organic compound by using this. So let us see how that how will you prepare the Wittig reagent. That is a important thing you must remember here, how to prepare Wittig reagent, similar to as you might be knowing as a Grignards reagent, how it is prepared and what are the application of the Grignards reagent. Everybody knows that Grignards reagent is nothing but as a RMGX is known as a Grignards reagent. How it is prepared? It is organometallic compound. How it is prepared? It is prepared just taken as a pure alkyl halide RX treated with pure magnesium metal in presence of the dry ether. The resulting complex form is called as a Grignards reagent RMGX. So in a similar way, the Wittig reagent also prepared by using as a Wittig reagent and the what we can call it as a Wittig reagent and the phosphine, triphenylphosphine over there, right? Suppose we have taken as a here, let us see as a alkyl halide. I am specifically chosen here. This is a alkyl halide, right? This is a structure of alkyl halide, and this alkyl halide treated with PPH3. PPH3 is called as the triphenylphosphine. This is the name of this compound, triphenylphosphine, and the resulting compound will be treated, that is in the step number first. What is going to happen in the step number first? This phenyl group is going to attack on that CH2 and there is a formation of salt. So like this, RCH, then R dash, here is a PPH3 positive charge over there, and here is a X minus charge. That is a salt form over there. That is called as a what we can call it as a Wittig salt. This one is called as a Wittig salt. Wittig salt is obtained over here, and this Wittig salt further treated with base, and this is a step number second. Step number second, further treated with the base. What is going to happen over here? The base, the function of base which will abstract the proton from here, we are going to get R, then R dash, minor charge over there, P, then PH3, here is a positive charge. This type of the species is known as an Elide. This is known as an Elide. What is Elide? What is Elide? This is a Elide. Elide is obtained by using as a alkyl halide treated with the base. Resulting compound obtained is called as a Elide. So one more question may appear in the exam. What is Elide? So this is an Elide. How it is obtained or how it is derived? It is derived or it is obtained from the alkyl halide, and the triphenylphosphine is the starting material used there, and the base anything we can use over there. Here is a phenyl lithium or Li alkyl lithium alkyl you can use, or you can use sodium ethoxide, methoxide, or that type of the base we can employ, or sodium hydroxide or the potassium hydroxide. By using that you can get as a this type of the compound. This is the Elide. What is Elide? This is the Elide. What is a betaine? When that compound, any Elide treated with carbonyl compound, the intermediate obtained, that intermediate is called as a betaine, and that betaine further treated, further get converted into as a alkene. So resulting compound obtained is a alkene over there. Let us see the example of Wittig reagent over here. What are the reagent? What are the application of the Wittig reagent? Suppose you have a starting compound. Let me draw over here. This is a what we can call a cyclohexanone. Everybody knows that. We have to bring regioselective. Why it is called as a regioselective? Regioselective means what? Whenever we are adding as a reagent, that reagent specifically attacks to that particular position, and therefore that is called as a regiospecific. And now here we are adding the reagent is a, suppose just now we have seen PH3P, then CH2. Here is a minor charge always this, and positive charge. This is called as Elide, right? And when Elide is treated with this, what is going to happen? You are going to get, first one is a formation of the betaine intermediate. How betaine intermediate is obtained over there? This is a what we can, for specifically you can arrange this molecule in this manner. PH3 here you write the proper, so that you can write here CH, not CH, let us see here, CH2 minor charge over there, and there PPH3 positive charge over there. For mechanism point of view we are writing like this: negative charge attacking over there, and this is going to attack over there, and you are going to get oxygen over there, and then here is a PPH3, then CH2, and this is a betaine intermediate, and this species is called as a betaine intermediate form. And that betaine intermediate, the driving force behind it, the affinity between phosphorus and oxygen is a great over there, and therefore there is a formation of double bond over there, and there is a double bond form over there, so that resulting compound will be obtained here, double bond CH2. So the double bond insert at outside the carbon-carbon double bond is a highly difficult, but Wittig, due to the Wittig reaction, we can easily introduce the carbon-carbon double bond and the resulting compound PH3 P double bond O. So this type of the side product is obtained over there. I think with this we have seen how we can prepare the different organic compound by using as a Wittig reagent. These are the application of the Wittig reagent, right? So let us see another modified Wittig reagent also there. Modified Wittig reagent means what? Here you have to attach some of the R group over there, you will get as a different type of the compounds. I think let us see one more example which can prepare over here, like suppose we have a benzaldehyde, right? Suppose we have a benzaldehyde here. And as we know that everybody knows that the structure of benzaldehyde is this one. This is a structure of a benzaldehyde. Then C double bond O I am writing over here, and one of the hydrogen atom here. And now the different Elide, the Elide like as a PH3 positive charge there, CH minus charge here may be as a CH2, then or CH double bond CH again double bond, and maybe as a here is a pH. This type of the reagent is called as a modified Wittig reagent. And this modified Wittig reagent also what is going to happen here, this negative charge is attacking on that carbonyl carbon, and this double bond attacking over there, and whatever resulting compound is formed is a betaine over here. So let us see here C H we can write here, then O, then PH3, here is a CH bond is formed there, then CH double bond CH and this pH, right? And now this is called as a betaine intermediate form over there. This is a betaine intermediate once again, and after that betaine is unstable, it is going to open like this form as a double bond, and this sigma bond broken and form as a double bond over there, and the resulting compound is obtained. The desired compound is this one. In this way, CH double bond CH, then CH double bond CH, and the pH, and the side product as we know that we are going to get this one PH3, that is a triphenylphosphine oxide. So that type of the compound is always obtained. So in this way we have seen as a structure of Elide as well as preparation of the Elide, or what is betaine. So that I think you might have get idea about that Wittig reagent, how it is applicable. The whatever reagent is obtained, Elide is a what we can call it as a phosphorus Elide. Similarly sulfur Elide or enamine, that are the different thing. But the Wittig reagent, George Wittig in 1954 reported a method of synthesizing alkane from a carbonyl compound, and which involve the replacement of carbonyl group C double bond O as we know that by the group double bond CRR dash, and during this reaction the nucleophilic attack by an Elide occur on carbonyl carbon to form a betaine intermediate, and which spontaneously undergoes elimination to yield an alkene. So that is called as a Wittig reagent, and some of the application also we have seen, and then after that we have seen as a structure of the Elide, what kind of the structures are there, so how it is get stabilized, that structure also we have seen. So let me again show you here the structure of an Elide, how that structure of Elide is there here. Suppose PS3, P double bond C, R and R dash. With this get stabilized, because this we can write here. This structure we can write by this resonating structure PS3, P positive charge, then C, R and R dash. Here is a maybe as a negative charge over there, and this type of the species, this is known as a Elide. An Elide we can call it as an Elide, or we can call it as a Elide. And this type of the Carbanion Elide form we have seen over here. So I think with this we have completed as a chapter number 4 over here. The name of that chapter is Carbanion and their reaction. What are the things we have seen here? Let us highlight, let us repeat those points. We started as this chapter. The name of that chapter is Carbanion and their reaction. First of all, we have seen the method of generation of Carbanion, and after that we have seen stabilization. What are the factors that stabilize the Carbanion? And after that we have seen what are the some of the famous name reaction involved by this type of the reaction. So, and after that we have seen two are the major synthetic reagent and their application. Is some of the famous reaction like as aldol condensation reaction we have seen, Claisen ester condensation reaction we have seen, then Dickmann cyclization reaction we have seen, and then what we can call it as a Perkin condensation reaction we have seen, and after that we have seen two synthetic reagent and their application like as a malonic ester, their synthesis as well as their application. How do we can prepare, we can synthesize the different organic molecule, that also we have seen. After that acetoacetic ester, its synthesis and its preparation, its synthetic application we have seen, and after that we have seen as a Wittig reagent. And in Wittig reagent, two things you should remember. What do you mean by the butane? Most of the students get confused. If the questions are butane, they are writing as an Elide. If the Elides are the inner question Elides are there, they are writing as a butane. So don't get confused between butane and the Elide. And Elide is prepared by the Wittig, that is called as a phosphorus Elide, or it is a reagent, and that reagent when treated with the carbonyl compound and whatever intermediates are formed, that intermediate are known as a butane intermediate, and which is further get converted into as a result an alkene. So that is called as a Wittig reagent. So let me tell you some of the important 1 mark question, or what we can call it as a 2 or 3 mark question over here. So list the factor affecting the stability of Carbanion. What are the factors? As we know, you just give the name of that factors only. We have seen percentage of S character, then inductive effect, resonance effect, and aromatization. At least 2 factors you must mention there, you will get as a 1 mark. Then then what is an Elide? Elide just now we have seen. Then arrange the following Carbanion in increasing order of their stability. Suppose there are given some of the species are there, you have to arrange accordingly how they are stabilized over there. So that type of the question may arise in the exam. Arrange the following Carbanion in increasing order of their stability. So they will give some of the Carbanion over there. Among that, keeping all these factors in mind, you have to arrange that compound. Then how will you obtain cyclopentane carboxylic acid from diethyl malonate? And as we know that diethyl malonate or malonic ester, one and the same thing you should remember over there. And or explain aldol condensation with an example and the mechanism. We know that aldol condensation reaction, simple aldol condensation reaction, cross aldol condensation reaction, and the intramolecular aldol condensation reaction. These are the different aldol condensation reaction, but here specifically mentioning as aldol condensation reaction, you should write only as a simple aldol condensation reaction. That's it. Or explain preparation of 1,1-diphenylethene from benzophenone with mechanism. And just now we have seen this 1,1-diphenylethylene will be obtained by using as a benzophenone also given. You have to give this we can obtain by using as a Wittig reagent, and that Wittig reagent, as we know that, and from by using, once you get the idea, it's very easy to write down that reactions over there. Or maybe how will you prepare 2-methyl-butane acid from diethyl malonate. Starting compound is given, as well as target molecule means final product also given. You have to give the suitable reagent, proper reagent in a proper order, there should be a sequentially you have to mention, and then you will get as a full mark, because organic chemistry is just like as a mathematics. If you give the specific reason, a particular reason, definite reason, and then you will get as a full mark. So in we are discussing about the important point about this chapter. Then what is Claisen ester condensation? Explain its mechanism with a suitable example. Claisen ester condensation reaction, we have seen ester also indicate as a ethyl acetate. You have to take and then two molecules, because there only see the nature of the question. You should understood the question, what is the question, and then accordingly you have to answer it. Most of the students are not getting the meaning of question, what they are asking, what is the nature of that question. So accordingly you have to give the proper reasoning, proper answer. Don't give the vague answer, don't take the burden of that organic compound. As I already told you that no alternative for the hard work. If you do the hard work at your this final year, you will have a bright future in front of you. So let us see another. How will you prepare 3-methyl-2-pentanone from acetoacetic ester? As I already told you, how will you prepare, how will you synthesize 3-methyl or 3-ethyl-2-pentanone from acetoacetic ester or ethyl acetoacetate, or maybe as a beta keto ester. So whatever it may be, but the structure is the same. We have learned only as a two synthetic reagent, and from that we have prepared the different organic compound. Then explain the preparation of cinnamic acid from benzaldehyde with mechanism. Cinnamic acid, here if you remember the starting compound, or it is a name reaction, but the questions are different here asking, and they expecting you know the Perkin reaction, because Perkin reaction, if you know, because Perkin have synthesized the end product or the final product, that is the cinnamic acid. What are the starting compound you have chosen, you have taken, and from that how he prepared with the help of suitable example we have seen with their mechanism that is expected over here. So in this way you have to remember. So these are the certain important what we can call it as a question may appear in your, then there is a predict the product one. Predict the product with justification. Justification means reasoning behind it or the explanation why you are predicting this. So in that way there may be as a some of the predict the product. I am not going to what we can call it predict the product, how we are getting that one, that we will see next time. But here there are the number of, and already we have learned these things. If you basically if you read this chapter thoroughly and then you will get the answer of each question. All are involved in that. So I think with this let us stop today here. Remaining we will in the next time we are going to start the next chapter. The name of that chapter is a very important one, that is a new chapter introduced, that is a retrosynthetic analysis and application, that we will see tomorrow. Let us stop today here. Thank you. Have a nice day.